Hello viewers, in today's session we are going to discuss one important problem from three-dimensional geometry, and here we are going to discuss this problem which is from a straight line, and here the topic is to find the equation of the perpendicular from a point to a given line and the coordinates of the foot of the perpendicular, right? So here we have this problem, that is we have to find the equation of the perpendicular from the point whose coordinates are 2 comma 4 comma minus 1, and a perpendicular is drawn from this point to this line, the whose equation is x plus 5 is equal to y plus 3 over 4 is equal to z minus 6 over minus 9. And moreover, we have to find out the coordinates of the foot of the perpendicular, right? So let us first draw a rough diagram to solve this problem. So here we are given a line, and suppose this line is L, and the equation of the line L is given as x plus 5 over 1. So here we can take 1, and then we have y plus 3 over 4 and z minus 6 over minus 9. And here we are given a point, say A, whose coordinates are 2 comma 4 comma minus 1, right? And suppose we drop a perpendicular from this point A to this line L, and suppose this point P is the foot of the perpendicular, right? So AP is perpendicular to this line L, and the equation of the line L is given by this equation, right? So let us take a scalar lambda here, right? So the purpose of taking this lambda is to find out the coordinates of this point P, which lies on this line L and this line, that is AP. So the coordinates of this point P may be obtained from this equation, that is the concept of a general point on a line. So we can now write x plus 5 over 1 is equal to lambda. So we'll frame three equations. So we have y plus 3 over 4 is equal to lambda, and z minus 6 over minus 9 is equal to lambda. So solving these equations for x, y, and z, we can now write x is equal to lambda minus 5, then y is equal to 4 lambda minus 3, and then z is equal to minus 9 lambda plus 6, right? So we have the coordinate, that is x comma y comma z, which is known as the coordinates of the general point on this line L, right? And for some special or specific value of lambda, we can have the coordinates of this point P, right? So x, y, z are given by lambda minus 5, 4 lambda minus 3, and minus 9 lambda plus 6. So here we can now write the coordinates of point P as lambda minus 5, 4 lambda minus 3, and minus 9 lambda plus 6. So for some particular value of lambda, we can have the coordinates of the point P. So now let us obtain the direction ratios of this line AP, right? So the DRs of the line AP can be obtained by subtracting these coordinates, right? Because we know that if we have a line and if we have 2 points, say A and B, and this point is x1 y1 z1, this point is x2 y2 z2, then the direction ratios of AB are given by x2 minus x1, and y2 minus y1 and z2 minus z1, right? So here we can take here x1 y1 z1. This point A can be taken as x1 y1 z1, and this point P can be taken as x2 y2 z2. So the direction ratios of AP are given by lambda minus 5 minus 2. Then we have 4 lambda minus 3 minus 4, and then minus 9 lambda plus 6 minus 1, right? So we can now write a lambda minus 7, then we have 4 lambda minus 7, and then we have minus 9 lambda plus 7. So these are the direction ratios of this line or this perpendicular AP, right? Now the direction ratios of this line L are obtained from the denominators of these three quantities. So the direction ratios of the line L are given by simply 1 comma 4 comma minus 9, right? So now we have the direction ratios of AP and the direction ratios of the line L. So now let us apply the concept of perpendicularity of two lines, right? Suppose two lines are perpendicular and their direction ratios are A1, B1, C1, and A2, B2, C2. And if these two lines, say L1 and L2, are perpendicular, then the condition is that A1, A2 plus b1 b2 plus c1 c2 is equal to 0. So here the direction ratios of AP are given by these numbers, and the direction ratios of the line L are given by these numbers. So here we can take a1 b1 c1 as lambda minus 7, 4 lambda minus 7, minus 9 lambda plus 7, and a2 b2 c2 can be taken as 1 comma 4 comma minus 9. So let us apply this condition. So we have AP perpendicular to the line L. So we have lambda minus 7 times 1 plus 4 lambda minus 7 times 4, and then we have minus 9 lambda plus 7 times minus 9, and this is equal to 0. So let us solve this equation in lambda. So we have lambda minus 7, then we have 4 times 4 is 16 lambda, minus 4 times 7 is 28, and here we have minus minus plus. 9 times 9 is 81, so we have 81 lambda minus 63 is equal to 0. So now we can collect the terms containing lambda. So we have lambda plus 16 lambda plus 81 lambda, and then we have here a minus 7 minus 28 minus 63 is equal to 0. So now if we add these three numbers, then we have 98 lambda, and here we have minus 7 minus 28 minus 63, and this is also minus 98. So this is equal to 0. So now from here we have 98 lambda is equal to 98. So lambda is 98 over 98, that is equal to 1, right? So for lambda is equal to 1, we can now easily find out the coordinates of this foot of the perpendicular. So P is the foot of the perpendicular. So taking lambda is equal to 1 over here, the coordinates of the point P are given by 1 minus 5. Then we have 4 times 1 minus 3, and then minus 9 times 1 plus 6. So we can now write the coordinates of point P as 1 minus 5 is minus 4, then this is 4 minus 3, that is 1, and minus 9 plus 6 is minus 3. So these are the coordinates of the foot of the perpendicular, that is the point P. So now the equation of this perpendicular AP can be written as x minus x1 over x2 minus x1 equal to y minus y1 over y2 minus y1, and z minus z1 over z2 minus z1, right? So this is the 2-point form of the equation of a straight line. So when we have 2 points, that is say x1 y1 z1, and this is x2 y2 z2, then the equation of AP is given by this equation, right? So here we can take x1 y1 z1 as 2 comma 4 comma minus 1, and x2 y2 z2 as minus 4 comma 1 comma minus 3. So this is x2 y2 z2, and this is x1 y1 and z1. So the equation of AP is given by x minus 2 equal to y minus 4 is equal to z minus minus 1, and in the denominator we can write x2 minus x1. So we have minus 4 minus 2, then we have 1 minus 4, and then we have minus 3 minus minus 1. So this is x minus 2 over minus 6. This is y minus 4 over minus 3, and then we have z plus 1 over minus 3 plus 1, that is minus 2, right? And here we can see that these denominators have the negative sign. So eliminating this negative sign by multiplying throughout by minus 1, so we can also write x minus 2 over 6, y minus 4 over 3, and z plus 1 over 2, right? So this is the required equation of this perpendicular AP. Now we can also find out the length of the perpendicular AP by using the distance formula. So AP is given by square root of x2 minus x1 square plus y2 minus y1 square plus z2 minus z1 square. So this is the distance formula. So substituting the values, we have minus 4 minus 2, that is minus 4 minus 2 square. Then we have 1 minus 4 square, and then we have minus 3 plus 1 square, right? So this is square root of minus 6 square. This is square of minus 3, and then we have here minus 2 square. So this is 36, this is 9, and this is 4, right? So we have now square root of this is 13, 13 plus 16 is 9, and here we have 4. So this is positive 7, right? So the length of the perpendicular AP is given by 7 units.